Welcome back to topic 11.7. This is Kirchhoff's junction rule this time. This is daily video number 1, where we're going to discuss conservation of charge and how that leads to Kirchhoff's junction rule. My name is Dr. Kelly Miza. I teach at Delaware Valley Regional High School in Frenchtown, New Jersey. So Kirchhoff's junction rule is pretty straightforward. It basically says the sum of the current that goes into a junction is equal to the sum of the current that goes out of a junction, AKA what goes in must come out. So any charge that goes in has to come back out again. That's what our conservation of charge tells us. So conservation of charge, the same amount of charge that goes into the junction in your circuit must also exit the junction. You can't just have charge appear or disappear. So let's look at an example. Here we have this beautiful circuit. We have a current coming in, boop, and then it hits a junction. It can now split into that first branch, or it can keep going into that second branch. So this is what we consider a junction when we're talking about the junction rule. Anywhere that current can split apart or come back together. So we have current number 1 going into that junction, and then we have current number 2 and 3 through those branches coming out of that junction. Then down here, they meet back together. So this is another junction. So at this junction, we have current number 2 and current number 3 going into the junction, and current number 1 coming out of the junction. So if we think about what that means in terms of our Kirchhoff's junction rule, that means current number 1 goes in, 2 and 3 come out. So current number 1 has to be equal to the sum of current 2 and current 3. So our first junction, I1 equals I2 plus I3. And then down at this other junction, we basically get the same equation just backwards. So I2 plus I3 go in and I1 comes out. All right, that's great. Let's put some numbers to it. So we have the current going through R1 is 10 amps. And the current through R2 is 6 amps. What's the current through R3? Well, going back to that same situation, I have this junction where I have 10 amps coming in. 6 of them go down through resistor number 2. So how many have to go through resistor number 3? Well, current in is 10. Current out is 6 plus whatever I3 is. So that means I3 has to be 4 amps. That's the junction rule. Probably one of the most straightforward things you're going to get in AP Physics C, E&M. Not going to lie. So enjoy it while it lasts. So to summarize, what should we take away? What goes in must come out. So sum of our currents coming into a junction has to equal the sum of our currents going out of the junction. And that's it. Thanks.